Hello, Doctor. I'm Anwarul Azizi bin Adani with metric number 2003048 I'm presenting to you my ICT infrastructure project titled Fixed Wireless Broadband Solution for PDPR at Kampong Tebuan, Simunjan. First, let us look into what is PDPR all about. PDPR is basically a home-based teaching and learning rather than physical attendance at school. The objectives are to ensure teachers can carry out teaching in structured and organized manner, while students are all given equal opportunities and access to education. It is not something new because it is already in the Malaysian Education Development Plan blueprint since 2013. However, it has gained popularity recently due to COVID-19 pandemic, where educators are compelled to find a way to proceed with learning processes, but still obeying to the current SOPs. So typically, PDPR can be done in three ways. But for the purpose of this project, we are going to focus on the online method, where students and teachers are equipped with the devices and internet in order for them to implement PDPR. Well, let's see what are the requirements for PDPR to be done online. First of all, they need the devices and the internet. The devices can be either PC, laptop, mobile phone, tablet, etc. For the internet, we require minimum bandwidth in order to run certain tasks. First, if the students would like to download digital content such as documents, ebooks, test papers, or accessing e-libraries, browsing to the web, basically they need at least 1 Mbps. Then video conferencing for online classroom, we need at least 4 Mbps download and 0.5 Mbps upload. Next, if they wish to use WhatsApp or Telegram to communicate with each other, they need at least 1 Mbps. Finally, should they want to stream videos or download them, they need at least 5 Mbps for HD quality, which is common format nowadays. Thus, when we look into all these requirements, the things needed for PDPR are device such as PC, laptop or tablet, minimum 1 each household, and for the internet, we need at least 5 Mbps of bandwidth per household. So let us look at our assignment scenario requirements. We have a rural village with 25 households. Every household are distanced and estimated of 300 meters from each other. They are having moderate 2G signal and weak 3G signal. Then, this rural village is located 30 km from the nearest town with established internet. Each household will be using laptop for PDPR, and so do the teachers. They must be connected to the internet for this purpose, and our task is to propose project for it. So looking at the scenario requirements, I have identified one example which is suited to the scenario. Here, we have Kampong Tebuan in Simunjan district. It is located 30 km from Kota Samarahan, which is the nearest town with established internet connections such as Streamix and Unify. Meanwhile, Kampong Tebuan itself has flat topography and located along coastal areas. Therefore, we might not have problems with line of sight. But we need to see. I'm going to explain that later on. They have an estimated of 25 households, sparsely distant from each other around 300 meters. They have electricity supply from grid. So this is the locality when we zoom into Kampong Tebuan, Simunjan. In addition to that, what are the challenges of this area? Kampong Tebuan has moderate 2G mobile connection. Therefore, with 2G, the villagers can only use it for calls and SMS, not internet. So they basically cannot browse or do whatever they want using internet because 2G cannot do it. So it is not suited for PDPR. It also has weak 3G mobile connection. 3G is good for internet despite low bandwidth and higher latency, but the problem with this area, they only can use 3G at certain times and most of the times they have network fluctuations. They also have one tower located at Kampung Hijrah, which is roughly around 5 km away. But the 3G is shared with many other villages such as Kampung Kelkak, Kampung Sageng, Kampung Lintang, and Kampung Sekendu. Due to scattered village locations, telco service providers are found to be reluctant to upgrade services in these areas. It might be due to almost stagnant population growth at that area caused by migration of the villages to bigger towns or cities. Average annual population growth rate for Simunjan is a mere 0.3%, which is very much less than Sarawak average. It also has no internet broadband facility so far. This area currently has no fiber broadband, ADSL and stuff, apart from the weak 3G cellular internet. The village is situated far from the nearest town with terrestrial broadband internet, which is, like I mentioned before, 30 km from Kota Samarahan, that has fiber and ADSL broadband like Streamix and Unify. ISPs might be reluctant to invest to expand to this area, maybe due to lack of demand or other social and economic factor, or simply their business strategy. Now we look at the proposed solution. Before that, let me explain the objectives of this proposal. First, we must satisfy the criteria as mentioned in my PDPR explanation before, which to make PDPR learning possible for both teachers and students to that area, where they can access to downloadable digital content, ability to carry out classroom video conferencing, ability to communicate between teachers and students via Messenger's app, and ability to stream or download and upload videos for references. I put all this as my primary objectives. As for the secondary objectives, we look at the infrastructure side of it. We should look into solutions that can optimize resources and minimize costs without compromising quality of services. There must have costs and resources required, but it must be optimized or minimized. Secondly, we need to go into performance. The proposed solution must have tolerable latency, sufficient bandwidth, or at least 5 Mbps like I mentioned before, and must have minimum downtime. Thirdly, we shall have equal access to all households by having a suitable topography architecture. Lastly, we must ensure the proposed solution is easy to maintain, have high availability option in the event of breakdown. High availability means more than one way to access the internet. Before I picked the solution, I went through several steps of identification and questions. Several options must be available in my hand. So after a series of education, studying and researching, I found 3 options available for the solutions. Option 1. Fixed Wireless Broadband or FWB. This option consists of installation of new antennas at 2 towers, both for receiving and transmitting microwave from backhaul fiber broadband, which the internet can be accessed by the household. It also involves installation of outdoor unit and Wi-Fi router at the house, and laying cables at the tower nearer to Kota Samarahan to the nearest fiber broadband line. So the advantages of FWB are: it is feasible to be implemented, it has reasonable costs, and the setup is not so complicated. It is scalable and future-proof, meaning in the event we need to upgrade the backhaul fiber internet speed, sure we can do that without having to upgrade or install new equipments. It is also accessible to all households, and all households will enjoy almost equal bandwidth and carry out PDPR. The maintenance is also quite reasonable. However, there are some disadvantages. It requires rental payment to Sakofa to place antenna at the tower. It also requires clear line of sight between antenna at the tower and outdoor unit, as well as from tower to tower. It also involves some substantial costs and ground survey. Next, we look at option 2, which is satellite internet via VSAT. We have an outdoor unit, satellite dish, which transmit receive signal to and fro from the satellite. Then it connects to satellite modem through coaxial cables, which will then be connected to every household via Ethernet cable. I didn't see wireless is feasible for this method because the distance between every household is quite far. Thus, using Wi-Fi router and repeaters might not be a good solution to this, as it may consume quite substantial power, plus it may cause some management issues later on. Satellite dish and router can be installed at the central location of the village. Advantages of VSAT, basically because it is ubiquitous and it is self-reliant, meaning we are not depending on other infrastructure to deploy, including payment of rental to towers, for example. On the other hand, disadvantages are high capital costs, meaning the higher the bandwidth or the higher the quota required, the more expensive it becomes. It is also self-maintained, meaning it may create management issues in the future because they might have problem arranging on which house to be located with satellite router, who's going to maintain, and some other logistics problem. Laying cables to each houses are not only costly, but require constant monitoring of ground condition. For your information, this place is famous for ground settlement. Every year we can see more and more land eroded and washed to the sea, so this can be a big headache later. But that's not the biggest one yet. The most important disadvantages to highlight is its bandwidth. With only 30 Mbps maximum we can get, if we divide it into 25 households plus the higher latency, we surely cannot do PDPR with such condition. Now let us look into option 3, upgrade cellular internet from 3G to 4G. It is actually the simplest solution, but the disadvantages is very clear. It depends a lot on the demand requirement by telco service providers. It can only be implemented if they are willing to invest, which is quite unlikely for scattered rural villages. So here it goes again, business strategy. Business strategy, demand and population requirements come again into picture for option 3. Hence, I don't consider option 3 for my project because it is too dependent on the telco service providers. For option 2, which is VSAT, I also eliminated it because it cannot satisfy PDPR objectives, which is to have sufficient bandwidth. Hence, I chose option 1 because its ability to fulfill all requirements and objectives of PDPR and this project. Let us break down on whether FWB can fulfill all the requirements and objectives. Plus, we compare it with the existing infrastructure. For primary objectives, FWB clearly can do all the tasks in PDPR like what we have listed. Meanwhile, for existing 2G, 3G mobile connection, it seems limited. They can only download small files or maybe at certain times, possibly with repeated attempts to connect and reconnect and disconnected. If small files are having problems, you cannot go further with video conferencing, communicating via WhatsApp and Telegram. What more to say video streaming and downloading? When we look at the cost and resources, of course, FWB has some substantial costs involved, but the good thing is we don't need to lay lots of cables, set up so much equipment, etc. to get the broadband quality services to these people, which is high-speed internet, where all households can have equal access. The maintenance is also minimal, and we can have high availability options. Meaning, in the event of breakdown, we can always switch to the existing 2G or 3G network, but without FWB, you don't have other choice. For the solution deployment, first we need to do topology analysis requirement. I have done a simple simulation to existing elevation profile from Kampung Tebuan to Kota Samarahan. Let us name the tower at Kota Samarahan as Tower A, while tower at Kampung Hijrah as Tower B. Tower A has elevation of around 26 meter, while Tower B has elevation of around 20 meter. Both towers' height are estimated to be 30 meters. Thus, we don't have problems with line of sight because there are no clear obstruction between Tower A and Tower B. Plus, the area between these are also very sparsely populated. Therefore, we may not have much problem with signal interference and frequency channel occupation. By using 7 GHz microwave, which can cover distance more than 30 km with good line of sight, repeaters or repeater towers are not required. To zoom in further, here is the elevation profile and how the line of sight can be illustrated. The proposed solution deployment involves two areas. One is at Tower A at Kota Samarahan and another one at Tower B at Kampung Hijrah near Kampung Tebuan. This is the line of sight. At Tower A, it involves installation of proposed high-gain antenna to transmit and receive signal through 7 GHz microwave with 1.2 gigabit per second capacity to Tower B. From this antenna, we may install a combo device to convert the signal. Then from there, we lay fiber optic cables to connect to the existing ones. Meanwhile, we shall install two antennas. At Tower B, we shall install two antennas. One is the high-gain antenna to transmit and receive signal from Tower A, then another multi-point antenna to connect to every household through 23 GHz microwave with 800 Mbps capacity. Outdoor antenna will be installed at each household premise. The network topology proposed for this connection is star topology, which multi-point antenna acts as a hub and every outdoor unit installed at every house as a client. We will have outdoor unit connected to the Wi-Fi router via Ethernet cable Cat6, which will then connect wirelessly to the laptop. Deployment of FWB is very common in many rural areas in the world, Sarawak included. In Sarawak, we have an initiative called MySRBN, or Sarawak Rural Broadband Network. It is an initiative by Sarawak government under Sarawak Digital Economic Corporation, or SDEC, to provide high-speed broadband services to rural areas. Currently, the network has set up 150 towers across 12 divisions and being deployed to 45,000 households to have unlimited broadband, unlimited internet access with up to 30 Mbps at affordable packages. Installation costs are borne by the government, while public Wi-Fi for schools, clinics, libraries, and other public amenities is totally subsidized by the government. It features a backhaul connectivity of up to 300 Mbps and contention ratio of 110. Antenna is to be located at the nearest Sakofa tower with an estimated 5 km radius from wireless point to multi-point antenna. The setup is very simple on the customer side, whereby installer may need to install outdoor unit and Wi-Fi router only. Repeaters or repeater towers are required for areas far from the fiber broadband sources. As a conclusion, FWB can definitely fulfill objectives of PDPR by enabling students and teachers to carry out learning and teaching processes. They can access websites, download digital documents, do online classroom through video conferencing, communicate with each other using various platforms, and also stream or download education videos for references. It is also an excellent choice for rural internet connectivity, especially for PDPR, which doesn't cost as much as VSAT, but at the same time have performance on par with fiber broadband. With Sarawak government willing to subsidize the installation cost, we also don't need to worry about ISPs who are willing to expand to those remote areas. Thus, it is aligned with Sarawak government initiatives and direction, especially under MySRBN. However, there is one thing that we cannot do here, which is FWB cannot be deployed to extremely remote areas where the location is too far from the backhaul fiber broadband. Therefore, VSAT may be a good option for these areas. I think, for example, like Bacalalan or Barrio, these areas, they are too far from the backhaul fiber broadband, so we might need to use VSAT for these areas. Nevertheless, for most of other rural areas, FWB is still the best option to be considered. Thank you, and my presentation. Thank you, and that is all for my presentation. Bye.